Hello everyone, this is a video lecture for Calculus 3, section 16.9, Divergence Theorem. This is the very last video lecture. So we have this formula here. We got double integral of f dot n ds is equal to the triple integral of the divergence of f dv. And we like dv because it's not ds. This is similar to what we just saw a minute ago with the Stokes theorem, but I'm pretty sure Stokes theorem had a curl of f instead of just f. So there is a little bit of a difference there. Anyways, the idea behind Stokes theorem and divergence theorem is to make things easier, and this one is indeed easier. So 169001, I got my f vector is equal to 4x xy 2xz, and they say this is over a cube bounded by the planes, and here we go, here's the big list: x equals 0, x equals 2, y equals 0, y equals 2, z equals 0, z equals 2. I don't think I need to draw that cube for you, but hey, well, might as well. 1, 2, 1, 2, 1, 2. And so we have this cube here. There you go. There's your cube. Okay. Well, we want to find the integral, whatever they're wanting, a double integral f dot d and ds or whatever. Let's just go and actually find my divergence of f. Obviously, we're going to do divergence theorem every time here. Divergence of f is kind of interesting because it's grad dot f, and the dot product makes it so much easier. So del x, del y, del z dot, and then this stuff here. 4x, xy, 2xz. And so because dot product, you just put like terms together, super fast and easy. Let me give myself a little bit of room here. And it's no longer a vector. Derivative in terms of x is a 4 plus sign. Derivative in terms of y is an x plus sign. Derivative in terms of z is a 2x. So therefore, 3x plus 4 is my divergence. So triple integral of 3x plus 4 dv. This is what we want. Well, this is super easy, because we saw it's a cube, 0 to 2, 0 to 2, 0 to 2, of 3x plus 4 d z dy dx. So, are there any z's? No. Go ahead and toss a 2 in the front. dy dx. Are there any y's? No. Toss another 2 in the front. Now we got a 4. Do we have any x's? Yes, this time. And so this would be 3 halves x squared plus 4x from 0 to 2. The 0 cancels everything. 2 squared is going to be a 4. Cancels with the 2 to make a 6. And then we got the 2 here. Makes an 8. So I got 56. There's your answer. Next question. The rest of these should go equally fast and easy. That's kind of the idea. The last section's actually a relief instead of a burden on you. So they're wanting the double integral of f dot ds, but they want us to use divergence theorem. Cool. I like divergence theorem. It's easy. Let's do that. So they give me my f is xy e to the z, xy squared z cubed, negative y e to the z. Okay. S is the surface of a box with the coordinate planes. So they're bounded by the coordinate planes. They're saying like 0, essentially. And x equals 7. So I'm going to put an and so you're not confused. We got y equals 2 and z equals 1. So again, it's not a cube, but it's a box. So They're saying, oh, go over the entire surface of the box. Well, we can rewrite this as a triple integral divergence f dv, and v is so much easier. So let's go and find my divergence first. This is actually going to be pretty simple as well. I'm not going to write it out. You already know what the formula is. And again, it's a scalar, so derivative in terms of x, I'm going to get a y e to the z. Derivative in terms of y, the 2 comes to the front. 2xy z cubed. And then in terms of z, basically it just stays the same because it was the z. You do not put commas. I don't know why I was putting commas. Again, I'm so used to cross products and stuff like that. This is a scalar. You put plus signs. There you go. So that is what we're going to be integrating. Oh, let me just go and put a minus there. Okay, dz, dy, dx. And so 0 to 1, 0 to 2, 0 to 7. And so keep cruising. In terms of z, we got e to the z doesn't do anything. We got z to the 4th over 4. So then we got y e to the z. I guess a 1/2 x y z to the 4. And then we get y e to the z again from 0 to 1, dy dx. The 1 gets plugged in everywhere. And so we actually get like e's and stuff kind of like that. Actually, no. Before we go and plug stuff in, notice one thing. Before we go and plug stuff in, look right here. Won't these cancel? Well, that makes it a lot easier. So plug in the 1 in right there. We essentially then would have 1/2 xy dy dx. Again, 0 to 2, 0 to 7. Okay, so in terms of y, squared over 2, so you're going to have a 1/4 now. X, y squared from 0 to 2. Plug in the 2, you get a 4, and actually the 4's cancel, so you get a 1 now in the front. 0 to 7, x dx. So that's x squared over 2, 0 to 7, 49 over 2. And there's your final answer. I'm telling you, this stuff is way easy. 0, 0, 7 now. Same thing, f is equal to 3xy squared, x e to the z, and then z cubed. And it says we want this along the surface of a cylinder. Y squared plus z squared is equal to 1. And the planes x equals -1 and x equals 1. So what does this look like? Well, it's a circle. It's a cylinder this way, basically. There you go. And again, from -1 to 1 for my x. So I'm probably going to switch to polar mode here in a minute, but we'll see. First off, let's start doing my divergence of f. So derivative in terms of x, I get a 3y squared. Derivative in terms of y, basically 0. And derivative in terms of z is a 3z squared. Notice what we have here. Y squared plus z squared, which I'm not saying equals 1 and you can just plug it in, but it's that circle. So if I were to do polar mode or something like that, I wouldn't be too far from the truth there. So triple integral, because again it's dv, of 3, I'm going to call this right here r squared, if that's okay. And then, of course, times r dz. Well, it's an x in this case, technically. dx, dr, d theta. Well, x goes from -1 to 1. Again, I'm just saying this. It would normally be z for cylindrical, but I'm just going to go x. Obviously, the same thing. My radius is 0 to 1. With my radius, there's a 1. And then 0 to 2 pi. There we go. Notice that we have r cubed. There's no x's, so I guess you could just toss an x in there. -1 to 1. Actually, I believe it's going to make a 2. So like 3/2, essentially. Let's not be hasty. Yeah, actually, it's a 2. No, 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 no. It's multiplied. Okay, let's not be hasty. Let's not be hasty, okay? Because I don't want to mess this up. So I don't have an x. So I basically just put an x there. And I'm going from -1 to 1. So plugging into 1, I get itself, and then minus a negative, see, it's doubling it, basically. So then I got 6. And then I have my double integral r cubed dr d theta. Because they're independent, really, you can do the 2 pi slide thing. And then I'm going to integrate this guy and get an r to the 4th over 4 from 0 to 1. Plug it into 1, obviously. I got here 12 divided by 4 makes a 3 and then a pi. And there you go. Last question, and this one's more of like a graphical one. So they say that I have an F force field, x to the 4th, y to the 4th, and they say plot this vector field. They're wanting to see what the plot would look like. What's going on is that you're going to get a lot of positives here, so you're always going to make that positive kind of case, but they're also the same. You can see the x and y are the same, especially along this line. So small little vector, and it gets bigger as you keep going. Small, and it makes it really big there. These are going to be vertical nearly, and this kind of turns on you. Turns. Bigger. Smaller. I'm just trying to make sure that you can see kind of like the picture here. Okay, close enough. So there's the picture. They're also wanting for this particular problem the divergence of f, just like find it. So I said, okay, this in terms of x is a 4x cubed, and plus this one in terms of y is a 4y cubed. There you go. That's all the questions I have for this section. It's actually pretty simple. Just repeat the process for the other ones. If you have any questions, of course, let me know. Thank you very much. Have a great day.